All right, so here we're dealing with secant angles once again. So again, when you have two lines intersecting, okay, you have an angle and its vertex is inside the circle, in the interior of the circle, but not in the center. Notice you create two arcs, one here and one here from your intersecting lines. Your angle is going to be half of those two arcs added together. So let's take a look at our example down here. We're asked to find the measure of angle PQS. So where's that angle? P down to Q, out to S. Uh-oh, it does create an arc, okay? Its vertex is inside the circle, okay? So it would be half of the two arcs added together. Problem is, I don't know either of the two arcs it creates, the one above or the one below. Instead, I was given information about the other two arcs on the circle. So what I'm going to do instead is I'm going to find this angle here. I'm going to call it angle Y. And then I'll use that angle to find the one I was looking for. So I'm going to do a two-step process here. So this angle, Y, its vertex is on the circle, is inside the circle also. It creates the arc of 100 degrees here, and then back behind it 32 degrees. So it also applies that the angle should be half of the two arcs added together. I'm going to call them arc 1 and arc 2. Okay, so our angle Y is going to be half of 100 plus 32. We go ahead and add those together. 132 divided by 2. And we get 66. Okay, so this angle, angle Y, is a 66-degree angle. We're going to use that to find angle X. And you might ask, well, how are we going to do that? Well, notice my X and my Y. Here I have a 66-degree angle, and here's the angle I'm looking for. I just kind of pop that out here. Notice they together form a straight line. How many degrees are in a straight line? Well, there's 180. So I know whatever my angle is plus 66 is going to have to equal 180, and I just subtract 66 to find the difference and see how many degrees are left. And I get 114. So the answer to the problem is 114 degrees for angle PQS. Again, what I had to do was find the angle next to it, or its linear pair, okay, and then subtract from 180 to find out what the measure of my angle was. Okay, here's a few more examples. Okay, we're asked to find in this first one, what's the measure of angle ABE? So again, here's my angle from A, to B out to E. I'm trying to find this angle right here. Again, notice, however, that I would need the arc here and here. I was not given those arcs. So instead, I'm going to find one of the angles next to it, say this angle here. Well, that angle its vertex is inside the circle, not on the circle, so I know I use that the angle is equal to 1/2 of the two arcs added together. The arc in front of the angle and the arc back behind it. So that would be the arc 37 degrees and 65 degrees. So I add those together. 37 plus 65 gives me 102. And divide that by 2. And I get that my angle Y is 51. So this angle here is 51 degrees. Well, again, we have a linear pair. The angle I was looking for, the one they actually wanted, is a linear pair or forms a straight line with this 51-degree angle. Together, those would have to be 180. So to find my angle, I'm going to take 180 minus 51 to find out how many degrees are left on that line for my angle. And when I do, I get 129 degrees. So the angle I was looking for, angle ABE, is 129 degrees. Okay, and here's one more. Maybe pause the recording, see if you can get this one on your own, then start her up again. So we want the measure of angle MNR. R. Our vertex for our angle, again, is inside the circle, not in the center, but just on the inside. And we notice it does create an arc here, and then back behind it, another arc. Okay, well, we know it's inside the circle, but problem is, again, we don't know the arcs. We do know the arcs for the other pair of angles. So I'm going to go ahead and instead find this angle here, and then go back and find the one they actually wanted. Again, its vertex is inside the circle, so I use the formula. The angle should be half of the two arcs added together. That gives me 1/2 of one of my arcs is 91 degrees and the other is 225. Add those together. Gives me 1/2 of 316. Divide that by 2 and I get that my arc is 158. Now that's not my arc. It's the other arc, or excuse me, angle. It's the other angle in the figure. I want the angle next to it. Again, notice together they form a straight line or a linear pair. So together they should be 180 degrees, and I should be able to go, well, 180 minus 158, how many degrees does that leave for my angle? It leaves 22. So my angle that I was looking for is 22 degrees. Again, I found the angle next to it using our property, and then used the fact that a straight line is 180 degrees total to find my missing angle. Okay, let's do that one more time. Here we go. We want the measure of angle EFH. So we start at E, down to F, out to H. So we're looking at this angle right here. Once again, our problem is that we don't know the two arcs that we need to know. We know instead the other pair, the 61 and the 35 here. So instead, I'm going to call this angle Y, and I'm going to find it first. Now, again, angle Y, its vertex is inside the circle, not on the circle. So my angle is equal to 1/2 of the two arcs added together. Whew, plug in the information. The two arcs I have are 61 and 35 degrees. Okay, so that gives me 1/2 of 96, which is 48. Okay, now that's not the angle they wanted. Be careful about that. They wanted this angle. I found the one next to it, and I found that that angle was 48 degrees. Now notice together the angle I need and the one I just found, together they form a straight line. So together they should be 180. If I take 180 minus the 48 degrees that I just found, it will tell me what's left for my angle that I actually wanted. And I get 132 degrees. So the measure of angle EFH is 132 degrees.